Section 1.1 Review of Functions. In our first example, we're going to review evaluating a function. So if f of x equal to 4x squared minus 3, we want to find f of negative 1 and f of a plus h. Now, basically, when we want to evaluate a function, you're just plugging in, right? So where the x is going to be substituted with negative 1. So we're going to take the same function, but where x is, we're going to plug in negative 1, and we're going to get a 1 for the first question. The second one, we're going to do the same thing, but instead of actual numerical value, we're going to do a plus h. So it's 4 parentheses x squared now replaced by a plus h squared minus 3. We're going to do a FOIL here, doing PEMDAS. So a plus h squared is a squared plus 2ah plus h squared. Distribute the poverty and minus 3, and that's our final answer. In our second review example, when given any functions, we need to be able to find domain in range and all the zeros of the functions. Now, zeros also known as x-intercepts. So, all right, so the domain. Now, if it depends on the question. Now, for this particular question, because, well, first of all, the x domain means what can x be? And x happen to be under the radicals. So, under this radical, and anything under radical has to be greater than 0. Right? So x minus 9 is greater than 0. So our domain is x greater than 9. X can be anything except 9, well, less than 9, because they'll make this radical less than 0. And the range can be anything. Now, any of these things could easily be checked with the graphing calculator. If you check the graphing calculator will also tell you where all the x-intercepts are. Okay, in this case, we have no x-intercepts. Right. Now, sketching a function using table values, I know we can easily use a graphing calculator, but in case we don't have a graphing calculator, the basic way to graph anything will be using an XY table. So if we let x equal to negative 2, negative 1, 0, 1, and 2, we plug in, just like evaluating in example 1, we evaluate f of x when x equal to negative 2, then our f of x or y value will equal to 5. And these are our coordinates. So at all these points or more, right? But these are some of the points on our function. So negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. All these numbers are on this graph, and this graph turned out to be a parabola. Now, the last example, using vertical line tests and identify characteristic about a function. Now, a vertical line test basically saying, if I draw a line vertically from up and down, okay, like this, where it's if a function it's well, what considered a function. Vertical line test will tell you that if your line only cross your graph of your function only once every time, you cannot have repeaters. So, for example, if you have a circle, if you cut through a circle, you will touch a circle twice. For this particular graph, which is the upside down parabola, when you draw a line through it, when you do a vertical line test, you will not touch your parabola more than once. So yes, so the this function, this graph passed a vertical line test. So this function is, I'm sorry, this graph is a function. Okay, now the domain, let's just look at it. Okay, what can x be? X pretty much stretch from negative infinity to infinity. So the domain is this symbol right here. R means all real numbers. Now the range, what can R be? Not R be. What can Y be? Well, Y starts right here. So Y equal to 1 is your highest value, and then we can expect to see graph all the way down. So it's basically from negative infinity to 1. So our range right here is y is greater than or less than, I'm sorry, not greater than, y is less than or equal to 1. From our graph, we can see the x-intercept is 1 and 5, and y-intercept is a negative 1. And the function is increasing, so function is going up. In other words, which part of the function, the slope, is positive. So the function is increasing from negative infinity, right, negative infinity to 3. At 3, that's when functions start going downwards, which is now it's decreasing. So increasing from negative infinity to 3, and after 3, the function will be decreasing. Okay, so function is not even because it's not symmetric about y-axis. So any function that's symmetrical around about the y-axis is considered an even function, and an odd function is anything that's symmetrical about the origin. And in this case, this particular graph is neither.